Hello developers. In today's video, we will know how to control a servo motor using ESP-IDF. So, let's get started. To control the servo motor, we need to use pulse width modulation. If you're not familiar with PWM, I would recommend you watch our previous video for better understanding. The servo motor SG90 works on 50 Hz frequency, which means a 20 millisecond period, and can rotate from 0 degree to 180 degrees. We can move the servo to specific angle by generating a PWM signal that has a pulse width between 1 millisecond and 2 millisecond, which is the standard range. But the extended range, which is from 0.5 millisecond to 2.5 millisecond, works fine with me. That means that, when we generate a PWM of pulse width 0.5 millisecond that moves the servo to 0 degree, 1 moves to 45 degrees, 1.5 moves at 90 degrees and 2.5 to 180 degrees, so that each angle between 0 and 180 has a specific pulse width. To generate PWM signal, first, we need to configure a timer, and give it a 50 Hz frequency. Second, we need to configure the channel, and give it the GPIO pin that will be used with the servo. Then, in the loop, we're gradually moving the servo angle between 0 and 180 degrees every 1 second, using a function that takes the desired angle, and returns the duty cycle that achieves this angle. We need the free RTOS libraries, and the LED-C library for PWM, and ESP-log library to log messages to the monitor. Tag macro to log the messages with the title, servo motor. I'm connecting the servo to GPIO pin 25. In the main function, we're creating a servo motor task, and give it the name, and stack size of 2 kilobytes, and priority 5. In the task, first, we're configuring the PWM timer, by giving it the speed mode, and the timer number to be used, and resolution, and frequency of 50 Hz, and the clock source. Second, we're configuring the PWM channel, by giving it the channel number, and the GPIO pin to generate PWM signal on it, and the speed mode, and also the selected timer above. In the loop, we're gradually changing the angle between 0 and 180, by a 10 degree step every 1 second. We set the duty on the channel and then update it. The set duty function takes the duty value, which is from 0 to 4095, because we choose a 12-bit resolution. So, this function will take the desired angle, which range from 0 to 180, and map it to the equivalent duty value. Build your project. Connect your ESP, and select the flash method, and COM port your ESP connected to. Click flash. Click monitor to open the monitor terminal. This is the hardware connection.